Welcome to the lesson video for day 2. This would be lesson 6.2 out of our Savas text. And we're talking about kites and trapezoids. Now these are some special quadrilaterals, four-sided shapes, that have certain characteristics we're going to look at in this lesson. So the first thing I want you to do is look at what this shape is. In this first example you see here, this is a kite. Before we jump into what this is in this example, we're going to take a look at our interactive student edition for lesson 6.2. And here's that essential question. How are diagonals and angle measures related in kites and trapezoids? If you needed to get a preview of the lesson vocabulary, it would be here. There's really only one term listed there. We're going to talk about a lot more. But down here at the lesson overview is kind of where we're going to start navigating through this. So that very first thing you see printed on this notes page is where it says critique and explain. So we're going to take a look at this. We've got a situation here where we've got a drawing done here in this diagram of this kite PQRS, where QS is that vertical line of symmetry over this design of a kite-shaped key fob. So Manuel, he makes a list of these conclusions from this picture on this diagram. So he says PR is perpendicular to QS. He says QP is congruent to QR. He says SP is congruent to SR. And so what he's probably done is he's probably taken some measuring tools and he's measured these things. And he's realized that those top two segments, QP and QR, they're the same length. The bottom two segments, PS and RS, or SP and SR, those are the same length. They're congruent. He's probably also measured that angle where those diagonals crisscross, or he looked at it and realized, oh, that's a right angle. So those are perpendicular diagonals of this kite. And he also found out that PR bisects QS. That means it cuts it into equal pieces. And he says that triangle PQR is an equilateral triangle, and he says triangle PSR is an isosceles triangle. Well, some of these are right, and some of these aren't quite so right, okay? So which of these conclusions do you agree with? Which do you disagree with? Okay, after you've thought about that a little bit, hopefully you realize that those first three are right. PR is perpendicular to QS, QP is congruent to QR, and SP is congruent to SR. Okay, but PR does not bisect QS. PR, running left to right, doesn't cut QS in half. QS can cut PR in half, but it doesn't work the other way around. And also, triangle PQR is probably not isosceles. Triangle PQR doesn't have three equal side lengths. Or sorry, is not equilateral. But triangle PSR is isosceles because those two sides, PS and SR, are congruent. Okay? So just to get you guys thinking a little bit about what the shape of a kite is, we're going to go ahead and take a look at our first example then. And this is where we would jump into the notes. Okay, so I'm going to show you this slide here, and then I'm going to go back and actually write in what you would need to write in on the notes. So for right now, just watch the screen. You don't have to write anything down yet. But we're asking how the diagonals of a kite are related. Now, this is what the diagonals are going to look like. We're going to show these diagonals here in just a minute. So here's what we know about kites, okay? First of all, we know the sides are congruent. We have certain sides that are congruent to make it a kite. We have two pairs of congruent adjacent sides. That means right next to each other. So AB and BC are congruent, but AD and DC are also congruent, okay? We also know this about the diagonals, and this is specifically what the question is asking. The diagonals are formed by connecting A to C diagonally across the kite, and DB across the kite forms that diagonal. And here's what you notice. We know that point B is equidistant from the endpoints of AC, and so is D. So they lie on this perpendicular bisector of AC. What that tells me is that segment AC is bisected or cut in half by segment BD, and it's done in such a way that that's a right angle where the diagonals intersect. So the diagonals of a kite are perpendicular to each other, and exactly one diagonal bisects the other. And that's kind of that overall statement about kites. So here's what we know about the diagonals of a kite. There's a diagonal, there's a diagonal. Let's try that again. So there's your diagonals. They intersect at a right angle, they're perpendicular, and one of them bisects a specific one. The one that is equally split in half is AC. So I know where the diagonals meet, we'll call that X. AX is congruent to CX. Okay, so here's what I know in words about the diagonals. The diagonals of a kite are perpendicular. They form a right angle. And one bisects the other. They don't bisect each other, but one of them will bisect the other diagonal. And again, this is some other information we know about kites from the definition of what a kite is, and you may have not seen this before, but in a kite, a quadrilateral is a kite if it has two pairs of adjacent congruent sides. Okay? So I want you to do the try it section. There's 3 parts to this try it section. You can do it on paper, but I also want you to confirm your answers by going on in that interactive student edition through Canvas. If you'll go through the Canvas 6.2 assignment, you'll see the interactive student edition. I want you to go to the try it section there and go to the second dot after example 1, and you'll see the try it section. It says, what is the measure of angle AXB? And if AX is 3.8, what is AC? And then finally, if BD equals 10, does BX equals 5? Those are these same questions here. I want you to take a couple minutes to try and do that. You'll want to pause the video here to give yourself time to do that. All right, if you still need more time, keep the video paused. Otherwise, this is what we should get. It says, what is the measure of angle AXB? AXB would have to be 90 degrees because that is where we get the right angle at X. Part B, it says if AX is 3.8, what is AC? Well, if AX is 3.8, it's bisected by this other diagonal DB. That means that XC would also be 3.8, but AC would be twice as much of that, or 3.8 plus 3.8. Or you could do it as 2 times 3.8, which would be 7.6. And finally, if BD equals 10, does BX equal 5? Well, BD is not the one that is being bisected or cut in half, so we don't necessarily know that BX is 5. Okay. All right, so let's go ahead and take a look at some information here. This is the theorem we just identified. The diagonals of a kite are perpendicular. Okay, so in this kite, I've got equal sides of 3 and 3 and 2 equal sides of 6 and 6. Those diagonals, WY and XZ, would have to be perpendicular to each other. They form a right angle. So in our example 2, we can go through and we can identify that because we can remember certain parts about triangles because all the angles of a triangle add up to 180 degrees. We also know that congruent triangles have corresponding parts that are the same. And because we have all these sides that are marked the same as each other, we can interpret that there's some of these triangles that are congruent to each other. So in this quadrilateral, it's a kite. What is the measure of angle 1? Well, angle 1, that's where you have your right angle. So the measure of angle 1 here is 90 degrees. Then it says, what is the measure of angle 2? Well, this is also a 90-degree angle. So if I kind of highlight that triangle specifically, angle 2 here is one of the other acute angles in that right triangle. Well, angle 2 plus 35 plus 90 has to equal 180. Okay? So I'm going to take 180, I'm going to subtract the 90 for the right angle, and I'm going to subtract 35 for that other angle they give me, and I'll get what's left as the measure of angle 2. Well, if I do 180 minus 90 minus 35, you should get 55 degrees. So the measure of angle 2 would be 55. Then it says, what is the measure of angle 3? Now I'm going to erase some of what I've done here on the picture to help you see this better. Angle 3 is part of this bigger triangle. Now this bigger triangle, because I've got congruent sides here and here, has to be isosceles. So this angle has to be congruent to this one. So angle 3 has to also equal 35 degrees. Because this triangle has to be isosceles. If I've got two congruent sides of a triangle, I've got to have two congruent angles of a triangle. Okay? So let's go ahead and continue on with the rest of the lesson. This is another try it section. I want you to take some time to do that. You'll need to pause the video here. Okay, if you need more time, go ahead and push pause again. But otherwise, this is what we should get. We have another kite. And again, we want to identify the different angle measures. Angle 1, that's this angle here. I am going to use this right triangle first. Because the diagonals are perpendicular, I know that's a right triangle. So all three of these angles, 32 degrees plus 90 for the right angle, plus the measure of angle 1, have to equal 180. So if I subtract these two from 180, the measure of angle 1 ends up being 58 degrees. Okay. Next it says, what is the measure of angle 2? Well, here's what we know about this triangle. I can do these a lot of different ways, but because these segments are equal to each other, and these segments are equal to each other, these two angles up here have to be the same because the triangle on the left, triangle on the right are exactly the same as each other. So I can easily look at that and realize, oh, measure of angle 2 is also 32 degrees, okay? Because this left side is the same as this right side. This segment splits that bigger triangle exactly in half, or splits the kite exactly in half that way. Okay, so that was related to the diagonals of a kite. Now we have some more information about trapezoids. Here's what a trapezoid is. A trapezoid is a quadrilateral that has opposite sides that are parallel, but only one set of parallel opposite sides. Okay, so like in this picture here, we have parallel side BC to AD. Those are marked parallel with those arrows. And this is considered to be an isosceles trapezoid because the two sides that are not parallel, so these two, are marked as congruent to each other. We would call those legs. That's a leg and that's a leg. The two parallel sides we would call a base. Okay? So in an isosceles trapezoid, each pair of base angles are also congruent. So angle A is 60. That means angle D would also be 60. So I can mark these base angles congruent. And these top base angles at B and C are congruent to each other. Okay? We also know that in an isosceles trapezoid, the diagonals are congruent to each other. So BD, this diagonal, is congruent to CA, this diagonal. But that's only for isosceles trapezoids, when those sides that are not bases are congruent. So here's what we have in our example. All the horizontal beams of this high voltage transmission tower are parallel to the ground. So we actually have some trapezoids here. We have this big trapezoid. And then we have this trapezoid, which I can go all the way to the ground with, or I can just do that part of it, okay? First of all, it says if the measure of angle 1 is 138 degrees, well, angle 1 is that angle. Let me try that again. Is that angle. It says, what's the measure of 2? Well, if this is 138, so is this one here. But angle 2 would be the same as this other angle down here. Remember that all four angles of any quadrilateral have to add up to equal 360. So I've got two that are 38 degrees, or sorry, two that are 138 degrees, plus two that are equal to the measure of angle 2, to equal my total of 360? Well, that means I'm going to double that. If I do 2 times 138, or 138 plus 138, that's 276. I'm going to take that away from 360. So 2 times the measure of angle 2 then has to equal 84, because 360 minus 276 is 84. I have to divide that equally. I have to divide that by 2. There's 2 of those base angles down here. So I have to split that in half, divide by 2. And that gives me that the measure of one of them is 42 degrees. So the measure of angle 2 is 42 degrees. Okay? And that's all I had to do in that problem. As we move on to part B, we're talking about another trapezoid here. And this is actually kind of zoomed in on this trapezoid. And it says one cross support in the center of the tower measures 4c plus 3, and the other measures 6c minus 5. What's the length of each cross support? Well, these cross supports are the diagonals of an isosceles trapezoid, because both of these sides, on the left and right, are 14. That makes it an isosceles trapezoid. So I should recall that the diagonals are congruent. That means they equal each other. So my equation is just 4c plus 3 equals 6c minus 5. Well, we can subtract 4c from both sides first. 6 minus 4 is 2c. Then the equation needs to have 5 added to both sides. That leaves 8 equals 2c. And then we can divide by 2. So that variable c has to equal 4. And then it wants the length of each support. So I need to plug that back in. If I do 4 for c, because 4 equals c, that's 4 times 4 plus 3. Well, 4 times 4 is 16. That's 16 plus 3, which is 19. I should get the same thing here. If I do 6 times 4 instead of c minus 5, that's 24 minus 5. That also equals 19. So the cross supports are each 19 feet long. All right, let's keep moving right along. Okay, I'm actually going to have you skip over this try it section for right now. If you want to go back and look at it later, you're welcome to do that, try it, and enter your answer in the Interactive Student Edition. But we are going to take one final look at our last big idea, and that is the trapezoid mid-segment theorem. Okay, so we have a trapezoid here. The segment that contains the midpoint of the two legs is parallel to the bases, and its length is half the sum of the lengths of the bases. Now that says a lot, but really this is the conclusion. So when I mark X as the midpoint of AB, it's exactly in the middle, and Y is the midpoint of CD, that makes this segment XY something called the mid-segment. Mid-segment, it goes exactly in the middle of that trapezoid. And what happens is it is also parallel to the other two bases, BC and AD. And its length is half of the sum of the bases, AD plus BC. So we can use this to help find missing measurements. So in this trapezoid, notice these don't have to be isosceles trapezoids. These are just any trapezoids. For part A of example 5, we're given that one base is 9, the opposite base is 13, and we want to find the midsegment. Well, that's a length here. And remember, the length of AB is equal to half of the sum of VW plus UX. Well, I know VW and UX. I know VW is 9, UX is 13. So I'm going to do half of that, and that's AB. Well, all I have to do is my PEMDAS. Do not worry about trying to distribute here. We can actually do what's in parentheses first. 9 plus 13 is 22. And I've got to do half of that. Remember, half means divided by 2, 22 divided by 2. 22 divided by 2 would be 11. Now, you can also do this by counting. You can look at the total distance or difference between these numbers. Okay, 9 and 13 are 4 apart. So I'm going to do half of 4. I'm going to go 2 up from 9 and, let me write that correctly, and 2 down from 13. And I should get to the same number. If I take 9 and I add 2, I get 11. 9, 10, 11. If I go backwards that same amount, 11 or 13 minus 2, minus 1 is 12, minus 2 gets me to 11 again. All right, so there's another way you could do that just by counting. And actually that helps a little bit right here on part B, because this time I've given you the mid-segment and we need to find the other base. Well, again, just do some counting. From 13 to go up to 19, we're just going to add 6. So I'm going to repeat that. I'm going to add 6 again. And 19 plus 6 then would be 25. That makes 19 half of the sum of those two bases. Now, when I do half of the sum of two things, this measurement is actually the same as just finding the average of the bases. Okay, when you add two things and then divide by 2, that's taking the average. All right, so let's keep moving on to these last couple examples. Paxton makes trapezoidal handbags for her friends. She stitches decorative trim along the top, middle, and bottom of both sides of the handbags. How much trim does she need for 3 handbags? Now that's important. 3 handbags. So we're going to find an answer for this one handbag, and then we're going to multiply it by 3. Okay, so let's keep on going. Now we know that this middle part of trim is the mid segment because it goes from the midpoint of each side of that trapezoid. Well, I need to find that measurement to include that in the amount of trim. Okay, I know the amount of trim needed for one handbag is going to be 6 plus that mid segment length plus 9. Okay, so I got to find that first. So to find that, we do the average of 6 and 9. Well, 6 plus 9. We're going to do half of that or divide by 2. 6 plus 9 is 15. Got to divide that by 2, which gives me 7.5. So that's what I add to those two. So if I add 6 plus 9 plus 7.5, I get 22.5 inches of decorative trim needed for one handbag. Well, I have to take that 22.5 and multiply it by 3, which gives me 67.5 inches of trim needed for 3 handbags. All right, our final example is a little tricky. We've got some other challenges thrown at us with this one, but we're still just dealing with a trapezoid mid-segment. Okay, we know that XY here is the mid-segment of this trapezoid, and they want to know what the length of KL is. Well, that's the other base. Now, we could just do some counting, but notice what they tell me JM equals. They say it's 4/5 of XY. That means I'm going to do 4/5 times whatever the length of XY is. Well, I know the length of XY, that's 25, so I'm just going to do some substitution. I'm going to take 4/5 times 25 then. Now, you might remember that I've told you to multiply by fractions. You just multiply by the top, then divide by the bottom. So if I did 25 times 4, and then divided by the bottom of that fraction 5, I get 20. 20 is 4/5 of 25, so this length is 20. Okay, well, they want the length of KL. Again, you can look at this by counting. So if the middle of these two numbers is 25, 25 is the middle of 20 and 30. Because to go up from 20 to 25, I add 5. So I'm going to repeat that pattern again. 25 plus 5 is 30 meters. Okay. Okay, and that actually finishes our notes for day 2. And you should be ready to start your assignment.